So we want to find an equation of a plane parallel to the plane 2x minus y plus 3z equals 4 and containing the point 1, 2, 2. So if two planes are parallel, then you can sort of imagine, so let's see if we can draw two parallel-ish planes here, that the normal vector to this plane and the normal vector to this plane are going to have to point in the same direction if the planes are parallel. So because this second plane is going to have the same normal vector, it's also going to have an equation of this form. And now we just need to figure out what that constant d is. So now we can plug in our point 1, 2, 2 for x, y, and z, solve for that constant. And so the plane that we're looking for is 2x minus y plus 3z equals 6. So now let's consider a case where we want to find an equation for a plane that contains a point, the point, let's say 1, 4, 2, and a line. So we know a line that's on the plane as well as a point. So now, if we think about what the equation of this plane tells us, it tells us that there is a point on this line, and that point is 0, 1, 4. Now, what does this part tell us? This part tells us the direction vector of the line. So it gives us a vector on the line, and since the line is on the plane, so is that vector. So this vector, negative 1, 1, 3, is already a vector in the plane. Now we need a second vector in order to find an equation for the plane, and so for that we can draw a vector from this point 0, 1, 4 to the point 1, 4, 2. And drawing that in, that gives us the vector 1, 3, negative 2. And now we can go ahead and find our normal vector by crossing negative 1, 1, 3 with the vector 1, 3, negative 2. And that's going to give us this normal vector here. Okay? And so doing the cross product, we end up with our normal vector, which becomes our coefficients on x, y, and z. Now, to find our value for the constant, we can plug in any of our points here, any of our 2 points. I think we'll go ahead and use this one. So plugging this point in, 0 for x, 1 for y, and 4 for z, gives me 1 minus 16 is negative 15 for d. And so the final equation for my plane is negative 11x plus y minus 4z equals negative 15. And so there is the equation for the plane containing this point and this line.